Assalamu alaikum. Dear students, I am Ahmed Mumtaz Mustesan with the second lecture on CSC 141 Introduction to Computer Programming. I hope you have gone through the first lecture and found it convenient. If you have any query, any question, please contact us through the course portal. Today I will continue with the fundamentals of the computer concepts. My lecture will be in two parts. The first part will be the fundamentals of the computer concepts, and then I will start with the introduction to programming languages. I have decided to quickly start the concepts of the computer programming, but just don't worry, I will not miss out any concept that you will require for this particular course regarding computers, the buzzwords, the concepts, and the terminology. Today I'll be focusing on the terminologies being used by the IT professionals, teachers, students, and computer vendors. It's important for you to know all these terminologies so that suppose if you are required to purchase a computer, you should be knowing the basic components and basic specification of the machine. I've also decided that I will be discussing these fundamentals of the computer concepts in my different lectures as fill in the blanks. Anywhere if I could find some space, so I will come up with few concepts. So side by side our computer programming learning, we would be able to learn the fundamentals of the computer's concepts, because that is the also part of this course. I've already given you the references, the reference books. There are some additional references. For this particular lecture, I have picked up some material from Programming Languages and Methodologies, and this book I have already mentioned in the reference. Then I have picked up some material from the website Wikipedia, a very popular website where you can find the definition of any concept. And then the third one is, you can see here, www.slipperybrick.com. So let's start lesson for the lecture number 2. You remember we talked about the memory of the computer, and I said that the memory of the computer is the workspace, is the archiving space, is the storage space, and then we had categorized the memory of the computer into two parts: volatile memory and non-volatile memory. And you know that the volatile memory requires power, so it loses its contents when the power is switched off, whereas the non-volatile memory does not require the power all the time to maintain its contents. So the volatile memory, we call it as a RAM, and non-volatile memory, we call it as a ROM. So let's go into the further details of the RAM. You might have heard the word DRAM and SRAM. Basically, DRAM stands for dynamic RAM. This dynamic RAM is used in the main memory of the computer. This is slower with respect to static RAM. Okay. The data which is stored in the DRAM requires to be refreshed periodically. So after a fraction of a second, within a fraction of a second, you are required to refresh the contents of the RAM. It consumes more power, once again more power, with respect to static RAM. Less desirable and cheap with respect to static RAM. So basically we compare apple to apple comparison. When we say dynamic RAM or DRAM, its apple to apple comparison is with the static RAM. So the static RAM is used in the cache memory. I'll explain it to you what is cache memory in few minutes time. It is faster than the dynamic RAM, and the data does not require to be refreshed. As I said, in the dynamic RAM, within a fraction of a second you are required to refresh the data, but for the static RAM you are not required to refresh the data. Data remains there, it is static, that's why we call it as a static RAM. It consumes less power. Obviously it's more desirable than the dynamic RAM due to these features, and anything which has more requirement is expensive. So it is expensive with respect to the dynamic RAM. Memory modules, SIM, DIMM and RAM. SIM stands for single inline memory module. It contains 72 pins and it transfers the data information over a 32-bit data path called the bus. I'll explain it in the next slide, but just I would like to show what is SIM. So on the top of our slide you can see a SIM, and these are the pins. So these are 72 pins, and for these 72 pins the data is transferred over a channel, over a bus, which is a 32-bit data path, 32-bit bus. Then we have a dual inline memory module called DIMM. Now the numbers of pins are 168 to 184, and it transfers the data on a wider data path, that is 64-bit data path. So once again, if you see a DIMM, it has got the pins on both sides, this side as well as on the opposite side of this DIMM, which basically provide the path for the data transfer. Obviously it has got a wider data path, double the strength of the data path or width of the data path of the SIM, therefore it is faster than the SIM. Then come RIMM, R-I-M-M, robust inline memory module, 184 pin, but it transfers information over a 16-bit data path. It occupies less space and hence it is sometimes preferred over DIMM or SIM. So once again you can see these are the connectors, or these are the data path. Let's talk about the cache memory. People used to call it as cache memory, cache memory, but now the word C-A-C-H-E has settled its pronunciation and it is called cache memory. Be careful, its spelling is C-A-C-H-E, cache memory. It's a very high speed memory, very expensive, therefore it's smaller in the quantity as compared to the memory of the computer, as compared to the RAM available into the computer. Usually with a memory cycle time comparable to the time required by a CPU to fetch one instruction. I hope you remember. the last lecture, in which we talked about the operations of CPU. Do you remember that? Yes. Fetch, decode, execute, and store the result. So this fetch requires the time, and the time is basically called the memory cycle time, which is compared to the time required by the CPU to fetch the instruction. This is within the cache memory, is usually within the CPU, part and parcel of the CPU. So within the microprocessor, but sometime it is not within the microprocessor. I'll explain it to you when I discuss the different level of cache memory. So the most frequently used instructions are kept in the cache memory of the CPU. So that saves time. It is just like a shopkeeper maintains more frequent item in the shop, whereas a less frequent items required by the customers are kept in the warehouse. So this is the smaller storage available within the CPU. So the instructions which are frequently used by the CPU are kept within the cache memory. So the time required to fetch the instruction from the memory to the CPU is much less, because the instruction is already available within the CPU. So as I said, it can be located on microprocessor chip or on a separate chip next to CPU, physically connected with the CPU. 3 levels of cache. One is called L1, primary or internal cache, located directly on the processor chip. And as I said, if it is within the chip, it is synchronized with the CPU, runs at the same speed as the CPU. Obviously, it is on a very luxurious place within the CPU, is a very, very luxurious place. Therefore, its size is very small. L2 cache, secondary or external cache, located directly onto the microprocessor chip or adjacent chip, runs almost at the same speed. It's larger in the capacity at the cost of speed, slightly slower than the L1 cache, and its capacity can be increased. That's why the capacity of the L2 cache is usually higher than the capacity of the L1 cache. Then we have got L3 cache memory, part of the system's motherboard. As I said, that it is located on the motherboard but has a physical connection, a faster bus, a faster data path from the CPU to the memory and memory to the CPU. This L3 cache is present in high performance systems like servers. So it has got the larger capacity than L2 and L1 cache. So there is a mistake on the slide. The larger capacity than L2, but slower than, obviously it's slower than L2, and if it is larger than L2, then obviously it is larger than L1 also. But the speed is slightly slower than the cache of the L2 category. So we have discussed the types and the terminologies of the RAM, which is a volatile memory. Let us talk about the types of the ROM. ROM maintains the data. It is the information which is permanently stored onto the chip. ROM stands for read-only memory. We have got PROM also. PROM is programmable read-only memory. Then we have EPROM, erasable programmable read-only memory. And finally we have got EEPROM, electrically erasable programmable read-only memory. Let's go through it very quickly. ROM, read-only memory, contains the information which is called firmware. Remember, we have talked about hardware, we have talked about software. Now a new terminology which is called firmware. Firmware, the definition of the firmware could be information permanently stored on a chip is called a firmware. Usually this information is provided by the manufacturer. So at the time of the manufacturing of this chip, the information is stored, the data is written, and this data cannot be erased or rewritten by the user. Next we have got programmable ROM, programmable read-only memory. This programmable read-only memory is available for the user to develop certain software, certain information, certain program, and then load it onto the chip and insert it onto the motherboard of the computer. But it is one-time programmable. Information once written onto the PROM cannot be erased. So depending upon the technology, PROM can be programmed at final stage, means once you have developed your program, debugged your program, tested your program, and you are 100% sure that it is working, it is operational, it is providing the service you expect and desire from it, then you burn this program onto the PROM. Writing the program, we use sometimes a terminology burn the program, because it has got the cells. When we write information onto these cells, we burn these cells so that the information is permanently saved onto these cells. Then comes EPROM, erasable programmable read-only memory. The difference between PROM and EPROM is, PROM you can write once, but with EPROM you can write multiple times, you can erase it multiple times, and still you can use it. But in order to erase the information that you have saved, you are required an ultraviolet box, a box having an ultraviolet light in it. You can place the EPROM within the ultraviolet box. It has got a window, and that you are required to take the chip out, put it into the ultraviolet box, and then erase it, reprogram it, insert it. We used to erase EPROMs in old days with the help of tube light. We used to stick this EPROM with the tape at the rod of the tube light with the tape. Usually ultraviolet box takes 10 to 15 minutes to erase the data, whereas if you stick it with the rod of the tube light, it will take 1 day to erase the data. But it has almost been obsoleted now. Okay, next is electrically erasable programmable PROM, EEPROM, electrically erasable programmable read-only memory. This is the latest and most commonly used ROM. User can modify the contents of the data without taking it out of the socket. While staying within the socket, you can use it, you can program it, you can erase the contents, using the programs that can generate electric pulses, that can erase the data, and then you can rewrite it. And the extension of this EEPROM is the flash memory. And this is the concept based upon the EEPROM, electrically erasable, programmable, read-only memory. With this technology, we have built up USB flash drives that you use to transport your data from one computer to the other computer. And the same technology is applied at the memory cards used in your mobile phone, on the camera, and some other devices which require the data to save within the device. I've picked up this beautiful picture from the website for which I have given you the link. Next is CMOS memory, BIOS memory. BIOS कहते हैं basic input output system. This is a small memory on the PC motherboard that is used to store BIOS setting. Basic input output settings. For example, the clock, the time clock, calendar, date and time, that is saved in this CMOS, saved in BIOS memory, having a technology called CMOS technology. So traditionally, it is providing the RAM, but this RAM is not volatile. It contains the information, then it picks up the power from the battery. Usually we provide a cell or a battery attached on the motherboard, so it draws the power from that cell and that battery because it is a RAM. The technology is metal oxide semiconductor. So CMOS stands for complementary metal oxide semiconductor. It is SRAM, which is powered by a small battery to retain the information. It stores configuration information about the computer. What type of information? For example, what is the type of the hard disk? What is the category of the hard disk? Similarly, some features regarding the fan speed of your laptop, the power consumption, the mode in which you want to use your processor installed on your computer. So these type of basic information are stored in the CMOS. Okay, let us now put the things together. The concept that we have learned up till now, we just would like to put it together. Processing. We said it requires input. The data is loaded into the CPU where it is processed, and then the processed data, that is the output of the computer, is recorded into the, and then it is transferred to the output devices. So how does it work? We have discussed input devices, central processing unit, CPU, memory, output devices. All these devices are connected together through a channel, through a path which is called a bus. This bus provides a path to these components to exchange the data among them. For example, if the data is required to be loaded into the CPU, it will first be loaded from the input device to the memory, and then from the memory it is loaded onto the CPU, where we call it as fetch. Fetch the instruction means load the instruction from the memory to the CPU. Then it is decoded, it is executed, and the output is stored back into the memory of the computer. And from memory of the computer, it goes to the output device, and then it is provided to the user. So the new concept that we have added is the channel path, or we call it as bus. There are different characteristics of the bus. We have a control bus, we have a data bus, but all these technical details you will study in your advanced course like computer architecture or in the operating system. Data flow for a computer job. First of all, the data flows from the input device into the memory of the computer. As you see in the slide, the input data is transferred from the input device to the memory. Then step number 2, from the main memory of the computer, it is transferred into the central processing unit. Then the central processing unit execute the instructions and write it back into the main memory. And finally, from the main memory of the computer, the data is transferred into the output devices. Step B and C usually repeated many times. That is, CPU brings the data into the register for processing, and then the CPU sends the processed data back into the memory. Why we require it many a times? It depends upon the data, it depends upon the instruction cycle, it depends upon the instruction, how many machine cycle an instruction takes, and how much data you are required to put in or take out from the CPU. And again, these concepts you will learn in some advanced course. Okay, finally we start the programming language. Whatever the concepts we have discussed up to now are the basic fundamental concepts of the computer science and IT. As I promised you in the beginning, please don't worry. At any time, any concept is required to be explained, I will explain it in detail. And while I will be discussing or delivering different lectures, I will be coming back with the fundamentals of the concepts. So, since I wanted to start the programming very quickly, so I have decided to just introduce you today what is a programming language. A programming language is a notational system intended primarily to facilitate human and machine. A notation which is understood by the human being as well as by the machine. That's why they can communicate. If you want to communicate with a Chinese who doesn't know English, and you are talking in English, or if you are talking in Urdu, he will not be able to understand that. So in order to communicate in a language among two parties, both the parties should know the language. So any language or any notation used by the language should be understood both by the computer as well as by the human being. A programming language has a syntax. and language elements have semantics. What is syntax? For every language there is a grammar, and in a grammar there are certain rules, certain procedures, certain protocols, and these rules, regulation, procedures, protocol is called a syntax of the language. The syntax of the language elements, I will come back later on what are the language elements, but you can say that any rule and regulation comes under the syntax of the language. Semantics, the meaning of these rules and regulation, interpretation of these rules and regulation, but very well defined and very well understood. ये कॉन्स्टिट्यूशन का कोई आइन की कोई शिक नहीं है जिसके लिए आपको सुप्रीम कोर्ट जाना पड़े उसकी इंटरप्रिटेशन के लिए. It's very well defined and very well understood both by the human being and by the computer. So let us define program. आपको याद होगा, I have defined a program as a set of instructions. Set of instructions given to the computer, what to do and how to do it. Today I defined a program in terms of the programming language. A program is something that is produced using a programming language. Obviously, if you are instructing a computer, you must be instructing a computer in a language understood by the computer. You cannot mix and match two languages to instruct a computer. First of all, you will select a language, whatever the language you will select, then you will follow the syntax and you will follow the grammar, rules and regulation, and then you will instruct the computer what to do. So a program is something that is produced using a programming language. So a program is structured entity with semantics. Why? Because the structure is follows certain syntax, and that syntax is understood. That syntax has already got certain meaning, certain semantics, so it is convenient and it is easy for both the parties to communicate with each other. So what is programming? A concept which is discussed each and every place. Someone says programming is a science. Some says no, programming is an art. Some say programming is an engineering. Programming is a skill. Don't worry. We say yes, programming is everything. Why? We say programming is a science because it implements the algorithms described by mathematics and science. Algorithms, I will come back to it later on. For the time being, I will just say algorithm is a procedure, a mathematical model. The solution to a particular problem described mathematically or described in any language, described in steps. So, using the programming techniques, you implement the algorithms described by mathematics and science. Therefore, we can say, yes, programming is a science. It's a skill also because it requires design efforts. Craftsman को craft बनाने के लिए skill चाहिए होती. So, programming के लिए आपको programming की skills आनी चाहिए. तभी आप एक अच्छा डिज़ाइन कर सकते हैं प्रोग्राम को. So it requires design efforts. Therefore, we can say it is a skill. Engineers usually don't agree. So we say yes, we can call programming as an engineering because it is a trade-off of 4 components. What are those 4 components? Program size, speed in which a program should be executed, time required to develop and debug that program, and finally maintainability, future maintenance. ऐसा नहीं है कि आपने प्रोग्राम बना दिया और बस it was lifelong. You are required to update the program. You are required to maintain the program, maintenance करनी. So basically, you might like to write a program which is very fast, very quick, but that will require a lot of space. So you need to compromise. You need to compromise with the space. So you say, okay, I've got this much space. My program should be fit in within the given space. So there is a trade-off now. So you have to consider the size of the memory available in which your program should be loaded. Then you have to compromise little bit speed of the program. Similarly, the time required to develop a program. You might write a program which is very professional, but it requires time to develop a very professional program. To develop a program and to debug a program. Debug means to take the bugs out, to find out the problems, to find out the errors, to remove the errors. So in computer science, or in the terms of programming, we call it as debugging. And finally, maintainability. Who is responsible to maintain this program in future? Is it you who has developed the program? Then whenever you will hand over this program to the end user, you will be required to go there, or you will be required to provide its maintainability, its maintenance. So we call that the programming is an engineering because it requires a trade-off between the speed, the size, development time required, and the maintainability. Finally, is programming an art? Yes. Programming is an art because it requires creativity and employ imagination. It's really your imagination how this program should be developed, what should be the algorithm, what should be the procedure. So no two person can write the same program. Every person comes up with his or her own ideas to solve a particular problem. So there could be number of problems, but it is the imagination of a programmer that he develops or she develops a program. So that's why it can be called as art, and it is the proper copyright of that person or the property of that person who has developed that particular program. Let's talk about the types of programming languages. You will listen this terminology again and again. First generation programming language, second generation programming language, third generation, fourth generation, fifth generation. First generation programming language was a machine language written in zeros and ones. I'll explain it to you in a few minutes. Second generation programming language, we have assigned the name, mnemonics, code assigned, name assigned, abbreviation assigned to these machine codes. So it was a second generation programming language. A third generation programming language is usually the high level language procedure oriented or object oriented. Fourth generation is very high level language. I'll explain it in few minutes. And fifth generation programming language is a natural language. Let's discuss the machine language. Lowest level of language, very close to the computer. In the first generation of computers, you were required to tell the computer what to do in a language that could be understood by the computer. The instructions were translated into ones and zeros. Remember, I've explained it to you that every CPU, every processor has got its own instruction set. So in the first stage, people used to have a card. Whenever they were required to instruct the computer, they used to take out the card and read out, okay, add 110, A into B, A is 10, B is 11. So the code becomes 1101110. It was very tedious, very difficult. Why in ones and zeros? Because computer is a bistable device. It has just got two stages, two states, on and off. So it was convenient for the machine, but it was very difficult for the programmers, for the users. So there came assembly language, which is a low-level language that allows a programmer to use abbreviations that could easily be understood by the user. These abbreviations were called mnemonics. Spelling देख लीजिएगा. Mnemonics थोड़े से different हैं spelling pronunciation से. The mnemonics are opcode and operands. For example, add AX, BX, move CX, AX, increment CX. Here the instruction part is called opcode or operation code, which is add, move, increment, multiply, divide, go to, jump. Similarly, operands could be, these are the registers, AX, BX and CX are the registers of the CPU. Within the CPU, you store the data in a register. That is again a memory within the CPU, very small size memory. So we assigned opcode and operands to the ones and zeros sequence, and these mnemonics are basically the abbreviations assigned to the sequence of zeros and ones. It was an improvement for the user because it was convenient for the user to write the instruction faster instead of writing a code 110, 10, 11. So now the programmer can quickly write down add AX, BX. But the drawback, the language is specific to a particular processor. मैंने आपको बताया था ना, हर प्रोसेसर का, हर CPU का एक अपना इंस्ट्रक्शन सेट है. Fortunately, unfortunately, machine language is dependent on this instruction set. So you require an assembler to translate assembly language program into machine language. Then comes high-level languages. English-like language, refinement of the second generation programming. So it was more convenient to the computer programmers because the notation were familiar. Numbers and abbreviations nahi hai. Notations are just like English keywords, English language keywords. And these high-level languages are not machine dependent. So you are not worried that you have to follow a certain instruction set. So it means that there is something, some piece of software that translate your high-level language program into low-level language. And this translator from high-level language to low-level language is either a compiler or an interpreter. In my next lecture, inshallah, I'll be explaining the difference between the compiler, interpreter, and some other related concepts. The languages are Fortran, COBOL, BASIC, C, and C++. These are all the high-level languages. Basically, these languages were built over and above assembly language. I do remember in 1983, I developed an interpreter which was basically a basic language-like interpreter that facilitated the professors to communicate with the single board computer using this interpreter. Not only contain the basic language commands, but also it contains the command to manipulate internal parts of the single board computer. We had a microprocessor college in Islamabad where the professors from multiple countries participated. They used this Mon base. I gave it a name, Mon base. They used this Mon base to teach IT professional for different exercises to communicate directly with the single board computer. So it's not difficult basically. If you develop the skills of programming, you can write down your own interpreters and own compilers. You can design your own new language. Just to encourage you, I have given this example. Then comes very high level languages called fourth generation languages, 4GL. Much more user oriented and allow programmers to develop programs with fewer commands, less commands as compared to third generation language. These are called non-procedural language. So the programmers don't have to specify all programming logic and tell the computer what they want and what the computer should do for them. So it saves a lot of time. It's very convenient, very easy to program the computers. These fourth generation languages consist of report generators, query languages, application generators, and interactive database management systems. The examples are RPG, that is a report generator, then SQL, structured query language used by different databases, and then we have few more. Natural languages, fifth generation, like ordinary human language, English language. So programming language that use human language to give people a more natural communication with computers. So you don't require the services of a programmer. if you have an access to our natural language. But it requires artificial intelligence. It's very difficult to develop such languages. So develop machine to emulate human-like qualities such as learning, reasoning, communicating, seeing and hearing. So these natural languages are developing very slowly, as a lot of research work is being done in the artificial intelligence. This is the evolution of programming. I've started it, although I picked up this slide and I've given you the reference in the beginning, but started in 1954 from the Fortran, but over and above this, before Fortran, we have assembly language, and before assembly language, we have machine language. But it started at Fortran, that later developed to Algol. So you can see the development takes place of different languages. Algol language produced multiple languages. We combined the features of the multiple language to produce a new language. So you can see there is from Fortran we have got Algol, and from Algol we have got BCPL, then B language, then C language, then the evolution came to C++, then from C we produce object-oriented C language, which was and also contains some feature from Smalltalk. From C++ we produced Java, and then we combined the features of Java and C++ to produce C#. So these are the categories which are given below. We have got declarative or imperative or procedural languages. These are different paradigms, programming paradigms. I will discuss it in detail in few minutes. Then we have an object-oriented, logical, functional and object-oriented, and on the left side you will see the years when these languages were launched. So we can see that the previous slide we could see different programming paradigms. These are procedural, imperative programming, functional programming, declarative programming, object-oriented programming, event-driven programming, parallel programming, and few more. But in this particular course, we will start with a procedural imperative programming language and will stay within that. The next course you will study object-oriented programming. I will give you the introduction of the object-oriented programming, and maybe in some other time I also would like to explain the functional programming and other programming paradigms. So let's move forward with our procedural and imperative programming. This procedural programming tells the computer what to do. So when we say do this, then do this, then do this, and if XX, do this, otherwise do this. So this is imperative. This is procedural. They focus on evaluating expressions and storing the results in memory. I have written here in a variable. I'll explain you the difference between a variable and the memory in the next lecture. The most common Imperative language consists of statements such as, suppose A is equal to 10, B is equal to 5, then we say C is equal to A plus B. So this is basically the example of an imperative language. Examples of the imperative languages are assembly language, COBOL, Pascal, C and C++. These are all the examples of the imperative language, where assembly language is a second generation and COBOL, Pascal, C and C++ are the high level languages. Which language is the best language? You cannot say that one particular language is the best. It is basically the application that determines that which language is most suitable. For example, for business-like application, the people prefer COBOL over Fortran, Basic, C and Pascal. When the people used to start learning the programming, they used to prefer basic language that has got some features which are available in Fortran, in COBOL and other languages, and simple and easy to program. For scientific purposes, C has come very late, in a very late stage. Fortran is there from the mid-50s. We had a Fortran, then we had Fortran 4, then we had a Fortran 77, then we had Fortran 90. So the Fortran stands for formula translation. It is basically most suited for the scientific programming. So in the scientific and research organization, R&D organization, people used to program the computers using the Fortran language. It was very popular among them. Then came the C language, and people started preferring C language as compared to Fortran due to some reasons that I will explain it to you. So the different languages are there. It's up to the end user to select the most suitable and ideal language for their task. But again, it is the choice of the users. People still use scissor to cut down their lawns when the lawn movers are there. So you cannot really force the people to choose a particular language for one particular task. So let it be the choice of the end users. But what should be the evaluation criteria? I'll give you some suggestions regarding the evaluation criteria. These are not the hard and fast rules to evaluate any particular language. These are just the suggestions. Number 1, readability. Myers programmer case in reading source code. Your written program should be read by another programmer. It should be readable. So one should be able to pick up the logic, the purpose of that statement or the set of statements you have used. So we call it as that the language should have a readability. Orthogonality include context sensitive restrictions. Means how much rules and regulations are applied and how much complexity a language has and how much sensitive it has in the development of the computer program. Applicability. Best tool for the best job. Are you using a COBOL language for a simulation program? It's not suitable. You can do the simulation in Fortran, you can do the simulation in C. So the choice of a COBOL language for a simulation may not be possible, or if you are doing it, then it might not be very efficient or might not be a good choice. Writability. Includes simplicity and orthogonality and support for the abstraction. These are certain technical terms that I promised to explain you in the near future. Reliability includes the type of checking and inspection handling. And finally, the cost. Cost in terms of time, cost in terms of resources required. So you have to be considerate to select a particular language and see how much cost it requires. Other are flexibility of control statements and availability of data structures. Again, it requires certain explanation that I promise to discuss in the next lecture. So we have finally selected C language for this particular course, which is a general purpose computer programming language. It was developed in 1969 when Dennis Ritchie and Ken Thompson, they developed an operating system called Unix. The first version of the Unix was developed in assembly language, or some part in Fortran language. It got its popularity. People liked it. So they decided to produce the next version of the Unix. Then they decided that before producing the next version of the Unix, Ken Thompson improved the available interface or available language and produced a language, called it as a B language. Obviously, it was more convenient, and the next version again was very popular among the end users, and they realized that they are going to produce a professional operating system. So finally they produced a professional Unix version. But before producing this professional Unix version, they improved the language, which was called B language, and named it as a C language, which by itself was very popular. It has got different standards. The initial one was called K and R because it was Carnegie and Ritchie who produced the first initial standard in 1978, and these standards were published and people used the language by following these standards published by Carnegie and Ritchie, which was called K and R. Around 10 years later, NCC was second C programming language standard, which was published in 1989. And finally, ISO certified it and approved another standard which was published in 1990. The latest standard, which seems to be a stable release, is called C11. So dear students, with this introduction, I stop here, and I think that the fundamental concepts and the introduction to the programming language that I have covered in this lecture will help you out in doing the programming, or while communicating with the other IT professionals, other students, vendors, you should be able to use the buzzwords and the terminology that I have introduced you today in this lecture. If you have any questions, any query, please visit the course portal and you can submit your queries over there. We would love to answer all the queries you have on this particular lecture. Thank you very much. Khuda Hafiz.